In next 5 minutes we are going to see NumPy demo. We will create mark sheet of 3 students for physics, chemistry, math, and also we will create static 1D array, dynamic 1D array, dynamic 2D array. So be with me. We are going to see NumPy demo. So this is simple example. You can see this is the physics marks of first student, physics, chemistry, math mark of first students, physics, chemistry, math mark of second student, physics, chemistry, maths of third student. You can see here we have taken the input physics, chemistry, math, and then we created the two-dimensional array. This is the two-dimensional array. This is the list we created initially, and then we created two-dimensional array, and you can see the first column is physics. First column is physics. Here 34, 41, 49 is the physics column. Second column is chemistry. Here 35, 14, 33 is chemistry column. Third column is math. This is math mark. 36, 45, 33. And you can see physics topper is student 3. 49, this is the first column physics. Student 3 is the first topper. Chemistry topper, second column is chemistry. 35, student 1 is the chemistry topper. And 45, student 3 is the math topper. Sorry, student 2 is the math topper, and total class topper is this is the student 3. Here you can see the total marks are 115. 49 plus 33 plus 33. Let us see the code now. Okay, I run the code one more time. Import NumPy as NP. Okay, and how to declare NumPy variable 1D array using np.array. So I run the code first. I run the code, and here you got the message: enter numbers separated by spaces. Enter number separated by spaces. So here I enter numbers 23 space 45 space 67. This is the program for dynamic array. Okay, so here we created a dynamic array. You can see here, as you see the code, import NumPy as NP. 1D NumPy array equal to np.array 11, 22, 33. This is the static 1D array we have created. You can see here 11, 22, 33 is the output of static array. That understand, static array हमने यहाँ पर तैयार किया 11, 22, 33. One way, first way to declare 1D array using NumPy. Here import NumPy as NP. First statement, pip install NumPy. What is the command? You have to install on command from pip install NumPy. Okay, afterwards import NumPy as NP. Then 1D NumPy array equal to np.array. This np, whatever variable you give here name, that name you have to write here. np.array means what? Suppose I write here a. Now I will write here a.array. Okay, so here I have mentioned NumPy np.array 11, 22, 33 and print 1D array. So I got 11, 22, 33. 11, 22, 33. Second way to pass the list as parameter to np.array. So what is the second way? My list equal to 1, 2, 3. This is the second way to declare NumPy array, 1D array. Print my list. Here if you see, this is the list 1, 2, 3, 1, 2, this is the simple list, and I am passing this my list as parameter to this function np.array, my list, and here NumPy underscore list, np.list, print NumPy.list. Now here I got 1, 2, 3. 1, 2, 3 is the output of this my list data structure, and here one no comma, there is no comma, 1, 2, 3. This is 1D array, 1 row, 3 columns, and here I get the list. Okay, now next program is I have taken the static input from the user. I want the dynamic input from the user. See, in this program I have taken static array. This is static array. This is static array. I want the dynamic array. So here I have entered the number 23, 45, 67, 88, 99, and I get the NumPy array. What is the NumPy array? If you see, NumPy array is here 23, 44, okay, you just check it, 23, 45, 67, 88, 99. Okay, so how to do it? It's very simple. Okay, simply take here user input, enter number separated by spaces. Okay, user input equal to, then number list, we are creating the list data structure equal to user input dot split space, means we are entering the space. Now what happened, this string, this is the string data get converted into list data, numbers underscore list data. Okay, but this is the string data. I have to convert this string, each string into integer. So here what I do, I convert it into integer. So what I do, for number in number list. Okay, I convert using for loop. I convert the number from string to number and I append it to the numbers 1D array. What is the 1D array name? Numbers. Numbers is the 1D array. Numbers is the list, and afterwards I am passing this list as parameter to the function. This is now the list. This list is passed as parameter to the function. Same example here. We have taken this list, passed the parameter as to this function. Sorry, this my list 1, 2, 3. Okay, I have passed this as a parameter to this function np.array. Only difference is here I am taken the static array. Here I am creating the dynamic array. Creating the dynamic array. Here this is the dynamic array. I am passing this dynamic array as parameter to the function and I get the output. Your NumPy arrays array. You can see here when I run the program, enter numbers separated by spaces. Enter numbers separated by spaces. I enter 23, 45, 67. The moment I press enter, the moment it stops to take the input, and here I convert it into string data types, numbers list, and afterwards I convert it into integers, and here NDI. So here if you see this, your NumPy arrays ARR, your NumPy arrays ARR, you can see this, your NumPy array is 23, 45, 67, 88, 98. Okay, next program. Now in next program what we are going to see, again let us understand, in next program we are going to create dynamic array. We are taking the input of physics, chemistry, mathematics of first student, physics, chemistry, math of second student, physics, chemistry, math of third students. We are going to write the same program here. This is 2D example of marksheet of 3 students. So again import NumPy as np3. I am creating another object, and here number of students are equal to int input how many students. Here I get how many students. If you see here how many students I am entering, I want 3 students. Okay, then enter marks of the students 1. So the moment I got this number of students, this is the mark list, empty list. Okay, and here what I do, physics array, physics variable, chemistry variable, math variable, and every time I append this into mark list dot append data structure. This is the mark list. Okay, so every time I enter the marks, physics marks, chemistry marks, math marks are appended in mark list dot append. Okay, and now let us enter the marks. Physics, so I enter marks 43, 42, 49. Then student 2, here I have seen enter marks of student I plus 1. Initially I is 0, then I is 1, I is 2. Student 2, I enter suppose 34, 56, 89. Then 11, 99, 33. Now here you can see this is the marks of first students, this is the mark of second student, this is the mark of third student. So initially this mark list, we are appending the mark list, and here I am printing mark list. You can see the output mark list. This is the mark list, and this is the list data structure output. I have to understand, this is the list data structure, means what? This is a mark list 0, this is mark list 1, this is mark list 2. This is the data structure, mark list. Are you getting me or not? This is the mark list data structure. Okay, mark list data structure 43, mark list 0, mark list 1, and mark list 2. And afterwards I am printing the mark list here. I got the output, and afterwards I am converting list to NumPy array by passing passing parameter to function. Already I told you, you have to pass parameter to function here. If you remember, second way to pass the list as parameter np.array list. Okay, so already I created mark underscore list function. I am just passing it with this function np array list. So here if you go and you can see np.array mark list is the mark array. Okay, so marks array, row student, column subjects, first column physics, second chemistry, third math. Okay, and here print marks array. If you see, this is the marks array. Print NumPy array. Here marks NumPy array. You can see marks NumPy array, marks NumPy array, and here I got first student mark, second student mark, third student's mark. First column is physics. These are physics mark. These are chemistry marks. These are mathematics marks. And from that, once I create this array name is my marks array. Okay, then I use physics topper equal to np.argument max. This is a function in Python for NumPy array, which calculate the topper in physics. Same for chemistry, same for math. Okay, and afterwards find total marks of each students. Here np.sum marks array axis equal to 1. So here what I get? Class topper equal to np.argmax totals. I get the total array. If I type here totals, then I will get totals of physics, chemistry, math, and here I will get physics, chemistry, math of first student, physics, chemistry, math of second student, physics, chemistry, math of third student. This result is stored in totals list. Means if I print totals, suppose I write print totals, I will get here what I will get? I will get total of first student, total of student, second student, total of third student, and this function will find the maximum marks index, and I get class topper here. So in this way you just execute the code, and you can see student 1 physics topper 43, student 3 chemistry topper, and student 2 student 3 chemistry topper. This is student 3 chemistry toppers, because second column is chemistry, that is 99. Physics, chemistry, chemistry topper is student 3, and math topper is 89, that is student 2. Math topper is student 2, physics topper is student 1, chemistry topper is student 3, math topper is 89, that is student 2, and class topper is student 2, this student 2, with total 34 plus 56 plus 89 is 179. So in this way we have covered mark sheet of physics, chemistry made of 3 students, static 1D array, dynamic 1D array, and dynamic 2D array. Okay, in next lecture, don't skip the lecture. In next lecture we are going to cover these methods. Okay, these are the methods for NumPy. Okay, NumPy with method np array, zeros, 1, full. Okay, we'll see this method program, then array info and shape. Okay, these are the functions which are used for shape. Then math operations are there. Add, we can add, subtract, multiply, divide, power, 2D array or 2 1D array, addition of 2 1D array, addition of 2 2D array, addition of matrices, subtraction of matrices, then square root. The statistics methods, np.mean, smallest value, largest value, np.max, mean, median. So these are statistic values, sum, product. Then sorting and searching operations, sort, where, unique. Okay, these are the examples. Okay, and afterwards array comparison and logic. We can compare 2 array, np.equal a, and we were comparing 2 array greater than, less than. These are operations. Then matrix operation, linear algebra operation, dot matrix of 2, matrix multiplication is there, transpose matrix. Okay, np.transpose. inverse matrix, determinant. So these are all mathematical eigenvalue, eigenvector. And the reshaping, we can change 1D array to 2D array, 2D array to 1D array. Okay, and we can create stack of horizontal stack, vertical stack. We can split array into parts. Boolean indexing means all the values greater than 5. Syntax is a greater than 5, like that. We can use multiple and operation. We can create file handling. Yeah, we can create file handling. We can create the file. We can like this. We can save the data in the file NPY. We can load data from file. We can save text data in a text file. We can save output of a program in text data, and we can input the file from the hard disk, from the current folder. So you just be there with me, and in next lecture I will cover it. Thank you.